Okay, let's see this simple question. Calculate the number of protons, neutrons, and electrons in this element. You have given the bromine. This is bromine with given 35 as subscript and 80 as superscript. So by this information, well, you have to calculate how many protons, neutrons, and electrons are there in the bromine atom. After uh, after Rutherford's that alpha scattering experiment, it was discovered that there was a conclusion that the mass of the atom is concentrated in the nucleus, and nucleus is very small. um, if the mass of the if we if, the size of the nucleus is around 10 to the power minus 15 meter, and that of the whole atom is around 10 to the power minus 10 meter. If there is an to understand the relative size of the atom and the nucleus, it's compared like if cricket ball is assumed to be the nucleus of an atom, then the radius of the atom will be around 5 kilometer. So that is the size of the nucleus compared to the whole of the atom. But the mass of of the atom is concentrated in the nucleus. So when we write any element with symbol of an element, suppose X, um, an element is defined, or an atom is defined. The most important characteristics of an atom, whether this atom will be atom uh, of which element, it's been determined by the atomic number, and the symbol is Z. And what does atomic number consist of? Atomic number is the number of protons in the nucleus, right? So well, this is an atom. In the nucleus, there will be the number of protons in the nucleus is the atomic number of the atom or the element. And since the charge on the one proton is the magnitude of charge in one proton is equal to magnitude of charge in one electron. So the number of in order to neutralize, since we know that an atom is neutral, so the quantity of the positive charge carried by the protons should be equal to the quantity of the negative charges carried by the electrons. So the number of protons and number of electrons that are around the nucleus is should be equal when it is a neutral in a neutral atom. We know that electrons can be given out, or it can be taken in the valence shell of an atom. So so atomic number is what? It's the number of protons in a nucleus. It will never change for an atom, and it will be the number of electrons in a neutral atom, not a charged atom. A charged atom may have one electron more, or one electron less, or two electrons more or two electrons less. But a neutral atom, the number of electrons can also be regarded as the atomic number. And what about the mass number? The mass, according to the Rutherford's alpha scattering experiment, it was one of the conclusion was that the mass of the atom is concentrated in the nucleus. Although the nucleus is very small, the whole mass is because of the nucleus. So what is mass number? Mass number is number of protons plus number of neutrons. Neutrons are discovered by Chadwick. They are almost the same size or same mass as the other protons, and they carry no charge. And why there was how this was discovered, it will be discussed later. So the mass of an atom is because of the protons and the neutrons in the nucleus, right? So their number, the sum of the number of protons and the number of neutrons, is known as mass numbers, denoted by A, and it is generally kept on the top of the symbol of the element. So mass number is what? The number of protons and neutrons. Protons and neutrons are collectively called as nucleons because they are in the nucleus of an atom. So let's come to our problem now. They give bromine. This is the mass number, this is the atomic number, right? Atomic number means what? It is the number, it's denoted by Z, and it is number of protons or number of protons in the nucleus, or number of electrons that are revolving around the around the proton. The Rutherford model of an atom, what the model of atom that is being proposed by Rutherford is similar to a small scale like us, our solar system, where sun is a nucleus and electrons like planets are revolving in a fixed orbit around the atom. This model will be proved later on wrong. It cannot describe any other phenomenon, but for the timing, it was one of the models proposed by Rutherford, it successfully explained many things, and it was concluded, and the picture was met because of the alpha scattering experiment that was conducted by him. So now, so in this case for bromine, we are now knowing the number of protons will be 35 in the nucleus, and number of electrons surrounding the revolving around the nucleus will be 35. So there will be 35 protons and 35 electrons. What about number of neutrons? So number of neutrons will be calculated from this mass number. Mass number is 80. What does it mean? It means that number of protons and neutrons is 80. We know number of protons is 35, right? Number of protons and neutrons is 80. So we know number of protons. So if we subtract the number of protons from this mass number, we'll get the number of neutrons. So it will be 45. So finally, and according to this, whatever information given over here, their mass number and atomic number, the number of protons will be 35, number of electrons will also be 35, and number of neutrons will be 80 minus 35, because this means neutrons, this 80 means neutrons plus protons, this is protons. So subtract the number of protons from here, you'll get number of neutrons, which is 45.